Recall in the last video, we found the means for these three sets, the set X, the set Y, and the set Z, which is constructed by finding the differences between each value in each set. Now let's find the variances for these three sets. Remember that the variance for a set of values is the average of the squared differences between the data values and their means. So, in other words, this sigma sub x squared, so the variance for the set of values that we've called x, and let's remind ourselves what x was. It was the set of values 4, 8, 12, and 16. So what we're going to do then is we're going to square the differences between each of these data values and the mean for the set, which was 10, and add those up. So we would then move on to 8 minus 10 and square plus 12 minus 10 and square plus 16 minus 10 and square, and then divide that by the number of terms that we have here, which is 4. And so that variance is going to turn out to be 20. Now let's do the same thing for y. Okay, let's remind ourselves that set y then was the values 2, 5, and 11. Okay, so again, we're going to find the differences in these values and their mean. So 2 minus 6, that mean was 6, and then square, and then we're going to add those up, and then divide by the number of terms we have. So that's then going to be 5 minus 6 squared plus 11 minus 6 squared. And then we'll divide that by 3 because we have 3 terms here. And that variance is going to turn out to be 14. Okay, now let's find the variance for the set Z, which was, again, the differences between the x values and the y values. And let's go back and remember what that set Z looked like. It was the set of all things that we would come up with if we found these differences between all the possible x values and all the possible y values. And we kept doing that until we got to 16 minus 11. And then that set consisted of those values 2, -1, -7, 6, and on out like this until we got to 14, 11, and 5 were the last 3 terms in that set. And then also remember that the mean for that set was 4. Okay, so this variance then would consist of every one of these values minus 4 and then squared and then divided by the number of terms that we have. So we would have 2 minus 4 squared plus -1 minus 4 squared plus, and we would keep on doing this until we got to this last one, 5 minus 4 squared. And there were 12 of those values. So we'd have 12 terms up there, and that variance is going to turn out to be 34. Now, something that we might note here is that the differences in these variances is not equal to the variance of the set Z. But what it is equal to, what this variance in this set Z is equal to, is the sum of those variances. In other words, 20 plus 14. So the variance in this set Z is equal to the sum of the variances of the sets X and Y. And that would have happened had we made these terms sums of the values of X and Y also. Now that leads us to a generalization, and that generalization is if a set is formed by adding or subtracting each value of one set from each value of another set, then the variance of the resulting set is the same as the sum of the variances of the original sets. And so to state that in math symbols, we would say the variance of this set that is formed by adding or subtracting each value of one set from each value of another set would be equal to the sum of the variances of the two sets. We must also note that the two sets X and Y must be independent.